This is an overview of a Java web service designed to allow for communication and data storage between clients operating on various platforms, microcontrollers, cell phone applications, desktop clients, or any device that's capable of HTTP communication. It's designed for use with an embedded systems network or an Internet of Things network, and to allow local or global control of any device on that network. This is the README page of the web service, and it has a diagram of how the service works, with the web service running on the Oracle WebLogic server, communicating with a SQL database that's stored on an Apache server. The database can hold configuration settings, sensor values, command values, things like that, output states for the different devices. I have various clients here, and they can connect through the web or directly on a local area network. An Android client, Arduino, or other microcontroller that's capable of HTTP communication, and a desktop client. Essentially, a device is turned on or connects, say an app is opened. It connects to the commander class of the web service, and it will receive all of its initial commands, anything that's stored in the database for that device, any states or commands or data that's stored in the database for that device will be pushed to that device, and the IP address of that device will be stored in an IP address table on the database so that the service can communicate with it. If a device wants to send a command to any of the devices on the network, it can do so by providing a device ID, a command or data field name, and the value for the command or the data field, and it sends that to the web service via HTTP commands. The web service will store that command in the SQL database and then push that command to the appropriate client. Each client has an HTTP server, a very basic HTTP server running on it, that is capable of listening for commands pushed to it from the web service. These are the main classes of the web service. There's a commander class that serves as the first point of contact when a client connects to the network. It makes a HTTP request against this class, and the class responds with all of the data or commands that were given to that device while it was offline. And during that request, this class also stores the IP address of the client for future reference, and it saves that in the MySQL database IP address table. This push command class is what actually sends the commands out to the devices with HTTP requests against each client's HTTP server, and it just contains the command name and command body for all of the commands, and it looks up the IP address of the device based on the device identifier from the table of IP addresses. This is a receiver class that listens for incoming commands from devices. It takes a device identifier, a command name, and a command body, stores that command in the MySQL database, and pushes that command out to the... there's a data source manager class that just manages the WebLogic data source for the Apache server in the MySQL database. And then there's a database communications class that actually handles all of the communication with the MySQL database, updating commands or looking up commands and IP addresses. This is the desktop client for the proof of concept of the web service. It just has a box for sending commands to other devices with a command name dropdown, a device dropdown, and then the command body goes in the box, and a colored panel that will react to incoming commands from other devices and change colors, and then this is just a box to list previous commands. It consists of a commander class that makes HTTP requests against the receiver class of the web service to send commands to other devices in the same format: a device identifier, a command identifier, and then the body of the command. And a listener class that is a basic HTTP server waiting for incoming commands from the push command class of the web service. This is the Android client I made as a proof of concept for communicating with this network. It's just got a grid of colored buttons, or buttons with a color name assigned to them, and a colored panel. And the colored panel will change colors when it receives a command from another device, and it can send other devices color commands using these color buttons. Aside from the main activity, it just consists of this listener class, which is basic HTTP server listening for commands from the push command class of the web service, and a command center class that makes HTTP requests against the receiver class of the web service. So to demonstrate, I have my colored panels that represent outputs, and then I have inputs in the form of buttons in the Android client, and up here I have a drop-down box. So the left is my desktop client. On the right is a jQuery script that is actually running on a third server, so it kind of represents a internet interface or a web-connected interface for the system. Right now I have it mapped to my Arduino command just to demonstrate. But obviously I could have an Arduino connected to this system as well. And it's bidirectional, so on the Android client here, if I change a color, and these are mapped to the computer, if I change a color, to the desktop client, excuse me. If I change a color, it updates on the desktop client. And on the desktop client, I can either send a command to the phone. I gotta type in the color here. If I send a command to the phone, it will react accordingly. I sent blue, it turns blue, and then if I were to send a command to the jQuery script, yellow, make sure I type it correctly, and it reacts and turns yellow. So all of these devices and any other device I had a system are all communicating with the centralized server and then responding to the commands as they happen in real time. So my motivation for this project and my plan for it is kind of a precursor and a platform for for a few projects I want to work on, some Internet of Things and smart appliance, smart device, and local area network projects that I want to do with Android applications and with the Arduino microcontroller. And this example is just a home automation system and security system. It could be running on the web service. You could have an Android client that can arm and disarm the system, control lighting, and alert the owner if there's problems or things like that. Arduino client would actually monitor the sensors, actuate things, turn on and off lights, stuff like that. And all of those state changes would come from commands that are stored on the database. You could have a desktop client that can be used to configure everything and set up these settings and set everything. You know, I could make a user interface, a control panel kind of thing to run the whole system. And then you could even handle things like email alerts. It can do automated response to problems, to alarms going off or to fire, things like that. You could do E911 calls through SMS from a desktop client. All of the command states and the sensor values and everything would be stored in the database, obviously. And then you could also have a remote desktop client that can run through the web that can function the same way as this for monitoring and configuring and things like that. So that's just an example of one of the kind of projects I have in mind for this system that I think it would be applicable to. And I am going to continue to do that and work with the Arduino and try to implement some of the designs I have planned. Thanks.